so we're talking about the process and how the bullet goes together. Why is it different? So the process is basically you're taking powdered metal, and so powdered metal, it looks like a dust, a fine dust, almost like sand. And we take and we put basically a adhesive in that material that glues the material together. So when you compress it, it goes together and it stays. So then once it's stuck together, then you drop that into a jacket, and that jacket basically just looks like a cylinder with a solid end on one end and an open end on the other. You close that, and then you flip it over into a die that makes the point, and then you've got a bullet. So there's all kinds of different shapes, obviously, that we use, different ballistic coefficients and things like that. And what we're trying to do is we're trying to make that bullet have less drag over a long distance, over maybe 400, 500, 600 yards, maybe farther. And so we make them different shapes so that they perform at those ranges. But the difference really is the core. And the core is made of copper, or it can be made of tungsten. Tungsten's extremely durable, extremely abrasive. And when it comes apart inside of tissue, that tissue is damaged. You can kind of see on this map that we have made, you can kind of see an up-close version. This was a 30 caliber, 175 grain bullet in a 300 Win Mag. And you can kind of see basically in the center here, this material. Now this is blown up about 2 times as much. It was really only about a 12 to 16 inch gel block. This is more like 24, so I guess it's not quite double, but times and a half. And so you see the damage. And generally, whenever you have a mushrooming bullet, a standard lead bullet or a ballistic tip or whatever, when those bullets come in, they start to mushroom, they expand, but they generally stay together. There are some bullets that don't, but for the sake of this argument, we're going to say that they stay together. And you will see the gel, there'll just be a straight line through it, and then you'll see the mushroomed bullet at the end of it caught in the gel or possibly in a second gel. And those bullets only cause about 1.5 times diameter of the projectile when it starts. So if it's a 30 caliber bullet or whatever, it's just 1.5 times bigger. With ours, you can basically see that it's the size of a soccer ball by the time you get done with the 300 Win Mag 175 grain bullet. And if that damage is caused at penetration, so it's through a shoulder bone or through muscle, and it's in the organs, it doesn't take long for whatever was hit to expire. So we're looking at tissue damage that can't be repaired versus a slice through, kind of like an arrow. It slices through. You can still sew that together and still have an organ or a material. With this particular product, you can't have that. It's totally destroyed. So the ability of this bullet to make animals expire quickly or more quickly than a lead bullet there's no comparison. So I use time to death as a guide for me as to how effective a bullet is. And to me, it's more humane to use a bullet that has a less time to death than something that's going to make animals suffer for long periods of time. That's kind of why we did what we did.